Alright, today I'm going to talk about transforming shapes with matrices. The first thing that I'm going to show you is just how to write points into a matrix. So I'm going to have this triangle right here, and I'm going to write these points, these 3 points, the vertices, as a matrix, okay? So first thing I'm going to do is I'm going to locate the points. So I got 1, 2, 1, 2, 3, 4, 5, 6. So I have the point 2, 6. 1, 2, 3, 4, 5, 6, 1, 6, 7, 8, 9, 10. So those are my 3 points. Now when I'm writing it as a matrix, the top row is all of my x's, the bottom row is all of my y's. So it's going to be x, y. So I'm going to it doesn't matter the order that I put them in. These ones, it doesn't matter the order. I'm going to go the point 2, 6, x and y, the point 9, 10, x and y, the point 6, 1, x and y. All right. Now we're going to change this matrix a few different ways today. There are a few different things that I can do. I can rotate it, I can reflect it, I can add to it, I can subtract from it, I can expand it, I can compress it. So the first thing would be, if I have this as matrix A, if it tells me to do something like 2A, what's happening here is I'm multiplying by 2. So what I'm changing is I'm expanding this. I'm expanding the matrix by 2 times. So all you need to do on this one is 2 times the matrix, which we've already done matrix multiplication. All we're doing here is distributing that 2 throughout the matrix. So it becomes 4, 12, 18, 20, 18, 2. So what happened here? This should have been a 6. My apologies, 12. What happened here is my triangle got 2 times as big. This is gonna go out 2 times as far now, okay? But what we're not seeing is we're not seeing it pushed into this region. It's not like it's just going out this way, which would make it bigger like this. It's getting twice as big, but it's getting twice as big and still staying in the same quadrant. So it came over here, and it's going like this. All right? So it's expanded by a multiplication of 2, but it's still staying in the same quadrant. Same thing would happen if I did 1/2 times matrix A. I'm just gonna multiply everything in the matrix times 1/2. So it's gonna be 1, 3, 9 over 2. Don't give me a decimal or a mixed number. 5, 3, and 1/2. Same thing, I compressed it, but it still stayed in that same quadrant, okay? Whoops, I'm off the screen. So that's what's going on there. I'm just multiplying by 1/2, all right? So those are the first 2 things. Next thing that we can do is we can change the matrix. What were my numbers? 2, 6, 9, 10, 6, 1. Okay, the next thing that I can do is I can multiply this by a matrix that looks like this. Now I want you to pause this video for about 3 seconds and just think about, what do you think is gonna happen to the matrix when you do this? All right, now that you paused it, we're gonna actually do this multiplication out. So remember, we do this row by this column. This is a 2 by 2, and this is a 2 by 3. They match, so we can multiply them. Whenever we're doing a transformation matrix, we're gonna put it first, and our resulting matrix is gonna be a 2 by 3. So I'm gonna do this row by this column. -1 times 2 is -2, plus 0 times 6 is 0. Now I'm gonna do this row times this column. -1 times 9 is -9, plus 0 times 10 is 0. -1 times 6 is -6, plus 0 times 1 is 0. 0 times 2 is 0, plus 1 times 6 is 6. 0 times 9 is 0, plus 1 times 10 is 10. 0 times 6 is 0, plus 1 times 1 is 1. So I don't know if you were able to notice this, but what changed here is everything on the first row became negative. Everything on the second row remained the same. So if everything on the first row became negative, that means that all of my x's became negative, but all of my y's stayed the same. So what did this do? I want you to pause it for a second and think about that and then tell me what it did. That's right. So what happened here? I feel like Dora the Explorer. I'm pretending like you answered correctly even though I don't know what you said. What happened here is that it reflected across the y-axis. Oh, and I'm off the screen again. I got a bad camera position today. Okay, let's see what I can do here. So it reflected it across the y-axis when I multiplied by this matrix. All right, now I'm going to change it a little bit. All right, again, pause it for a second and just think about what's going to happen here. And I'm going to go a little bit faster just because I don't want to make this video too long. So what's going to happen here? This row times this column, this row times this column, this row times this column. Nothing in the first row is going to change. This row times this column, this row times this column, this row times this column. Everything in the second row is going to change sign. So think about that. What does that mean? All of my x's stayed the same, but my y's changed value. So that's reflected across the x-axis. And for the sake of time, for the sake of uploading time, I'm going to start a new video.